Derived quantities are the one which takes the help of the base quantities. The equation which is obtained on equating the physical quantity with the help of the dimensional formula. Only if there is a presence of same dimensions, only then you can either add or subtract it. T is in the denominator. When it comes up to the numerator, what happens to the power? Power becomes negative of whatever power is present there. Hello everyone, I'm Brinda, Faculty of Physics, Vidhyaashram Pre-University College, Mysuru, welcoming you all to the session 6 of chapter 2, that is Units and Measurement. In today's class of ours, let us discuss regarding the dimensions. So first of all, the dimensions, what are these dimensions? Dimensions are the one which represents the physical quantity, that is, which represents the nature of the physical quantities. So you all know what are those physical quantities, the quantities which are observed, the quantities which can be felt or touched, all these are the physical quantities. So the dimensions are the one which represents the nature of the physical quantity. So there are two types of dimensions. They are base quantities as well as derived quantities. We have got two types of dimensions, that is base quantities as well as derived quantities. The dimensions for base quantities as well as the dimensions for the derived quantities. So, in case of base quantities, here we have got 7 dimensions of the physical quantity, and it is always denoted by square bracket. It is always denoted by square bracket, wherein the square bracket is very much important. Without mentioning the square bracket, it doesn't seem to be a dimension. So these base quantities are called as 7 dimensions of physical quantity. So which are those 7 dimensions of physical quantity? Which are those base quantities which cannot be derived from others or which cannot be derived by other quantities? Itself it is a base. So it is a base quantity, that is length, which is determined by L, capital letter L, within the square bracket. Similarly, mass, it is represented by M within the square bracket, and time, it is represented by capital letter T within the square bracket. So length, mass as well as time is clear. Next, it is electric current, which determines the current, that is, it is represented by A, ampere, that is A. So it is also enclosed by the square bracket. Thermodynamic temperature, the temperature is represented by Kelvin, so it is K. K, it is enclosed within the square bracket. Next is luminous intensity. So what is this luminous intensity? Luminous intensity is the one which determines the temperature of the celestial bodies. So when it comes to the temperature of celestial bodies, it is measured in terms of candela. So CD, candela, it is enclosed within the square bracket. Again, the amount of substance which is measured in terms of mole, so MOL is enclosed within the square bracket. So these are the 7 standard or the 7 base quantities. So now coming to the derived quantities. So what is this derived quantities? So derived quantities are the one which takes the help of the base quantities. So having the base quantity only, you can give out the derived quantities. So the quantity which derives the things from the base is called as derived quantities. So here it is derived using the base quantity dimension. So it derives the base quantities dimensions, and the dimensions is given here. Those are called as derived quantities dimensions. So for example, we have got volume. So what is that volume? How do you calculate volume? It is length into breadth into height. It is L into B into H. So length into breadth into height. So what happens when length into breadth into height comes into picture? So it is length, it is determined by L. Breadth, it is also the calculation of length itself. So it is again L, and H, height, is also the calculation of length, that is L. So I can write this as L into L into L. So what is the dimension of L, that is length? It is capital letter L within the enclosed within the square bracket. So we have L into L into L, it is L cube. So it is enclosed by L cube. So this is the derived dimension of the volume. Next it is force. So how we calculate force? Force is equal to mass into acceleration. This is how we calculate force. Force is equal to mass into acceleration. So what is the dimension of mass according to this base quantity? It is m. So can I write m here? Yes, I can. So which is equal to m enclosed within the square bracket, which is enclosed within the square bracket. Next it is into acceleration. Acceleration is rate of change of velocity with respect to time. So velocity by time. So it is velocity by time. So what happens to the velocity again? Velocity is equal to distance by time taken. That is the formula of velocity. Velocity is equal to distance travelled by time taken. So my V changes to D into T. So how can I give the dimension equation for this? D divided by T into T. So T into T, that is time. Time is given in terms of capital letter T enclosed within the square bracket, and D is nothing but distance. Distance is calculated with the help of length. You are calculating distance, no? So it is length. So it will be L. So my dimension formula by D divided by T square goes like L divided by T square. So finally you have force is equal to M, L, T is in the denominator. When it comes up to the numerator, what happens to the power? Power becomes negative of whatever power is present there. So ML, T, here it is square, it becomes minus 2, negative of the power, and single square bracket is sufficient. So force is equal to MLT minus 2. This is how you derive the dimensions. By using the base quantities, you derive it for derived quantities. So now, next coming to dimension formula as well as dimension equation. So what is this dimension formula? The expression which shows how and which of the base quantities represents the dimension of a physical quantity. Which of the base quantity, the expression shows that which of the base quantities represents the dimension of the physical quantity is nothing but the dimension formula. So what is this dimension equation? It is the equation obtained on equating the physical quantity with the dimensional formula. The equation which is obtained on equating the physical quantity with the help of the dimensional formula. So I hope you are clear with this dimension formula as well as dimension equation. So next is application of the dimensional formula, that is deducing certain relations among different physical quantities. It is used to deduce the relation between different physical quantity. I'll come to that. You'll be clear with the things. Okay. So next is accuracy. So what is this accuracy? It is nothing but the correct form of it, like correctness, very close to the correct value. So dimensional consistency. So what is this dimensional consistency? That means the left hand side as well as right hand side both contains same dimensions. That is, it is made to reduce to the same dimensions on both the sides. That is nothing but this dimensional consistency. And there is a principle which I'll be teaching you in the next slide. So homogeneity of various mathematical expression. Homogeneity, that is the identical. So homogeneity of various mathematical expression, that means the mathematical expressions is made identical with the help of this dimensional formula. So the applications of dimensional formula are: one is to deduce the relations among the physical quantities, and accuracy, that is closeness to the correct value. So being accurate, and dimensional consistency, that is both the side, that is towards left hand side as well as right hand side, you are reducing the equations in order to maintain the consistency. Okay, then it is homogeneity of various mathematical expressions, that is identical mathematical expressions. So next is dimensional consistency of equation. So we have got a principle, a simple principle to explain this consistency of equation. That principle is known as principle of homogeneity of dimensions. It is principle of homogeneity of dimensions. Here the magnitude, that is the number, magnitude means it is the number. Okay, so the magnitude of a physical quantities may be added or subtracted together from one another only if they have the same dimensions. So only if there is a presence of same dimensions, only then you can either add or subtract it. This principle is known as principle of homogeneity, that is identical. Okay, homogeneity of dimensions. So if the dimensions are identical, only then you can either add or subtract it. This principle is known as homogeneity of dimensions. And next we are going to deducing the relations among the physical quantities. We are deducing the relations among the physical quantities. This I told you, this is one of the application of the dimensional formula. So how are we going to deduce the relation among the physical quantity? So we have to consider a simple pendulum. It is a simple pendulum, that is a bob which is attached to a string. So which oscillates under the action of force of gravity. So the bob is having a oscillation under the force of gravity and it is attached to a string. So you got to know a simple pendulum, how a simple pendulum looks like. A bob, it is attached to a string and it is undergoing oscillations, okay, under the force of gravity, under the force of gravity. Suppose that the period of oscillation of a simple pendulum depends on its length, mass of the bob and acceleration due to gravity, that is g. So what do we have? We have length of the string, that is L, mass of the bob, that is given in terms of m, and acceleration due to gravity, that is given by g. So we have to derive the expression for this time period. So how are we deducing the relation? So now, so time period here, it is depending on L, M and G. So it is proportional. So proportionality constant comes, time is proportional to length, mass, acceleration due to gravity. So how it comes in the sense, the K, it is the proportionality constant which is into L to the power of X, G to the power of Y and M to the power of Z. Okay, so now what do we have in T? T is nothing but L is 0 because there is nothing. M is also 0, there is nothing. And T, there is presence of 1. So it is T to the power of 1 which is equal to, what is this K? It is proportionality constant. So leave constant as it is and we have got length as L into X and g, it is acceleration due to gravity, and acceleration is due to gravity is given by meter per second square, which can also be given as meter second minus 2, where meter is given in terms of L, that is length, and second is given in terms of time, that is t. So I can give it as t minus 2. So I can get this equation here, that is L t minus 2 into y, and my mass is capital letter M to the power of z. So now we have got L as x plus y into t as t minus 2y and my m as it is z. So now equating LHS and RHS. So this is my LHS and this is my RHS, that is left hand side and right hand side. Now, so consider only the similar terms. Similarities has to be there. So L as well as L, homogeneity. Okay, so it is L to the power of 0, L to the power of x plus y. So only take up the powers. So it is x plus y is equal to 0. So what happens to your x? X becomes minus y. X is equal to minus y. So next is, you have just got the algebraic term of it, so you have to get the numerical term. So in order to get y, you will have to calculate for this minus 2y. So it is minus 2y, that is the power of t and power of t in the left hand side. So power of t on the right hand side as well as left hand side, you have to equate it. That is minus 2y is equal to 1. So y is equal to minus 1 by 2. So y value is minus 1 by 2. So here you have got minus y. So it is minus of minus y value, that is 1 by 2. So it is plus 1 by 2. So you have got x as plus 1 by 2 whereas y as minus 1 by 2. So next it is the value of z. So z is equal to 0. Z is equal to, in terms of left hand side, it is to the power of 0, here to the power of z. So z is equal to 0. So you have got the value of x, that is half, y is minus half and z is equal to 0. Substitute the same for x, y and z in equation 1. So you have got t is equal to k into Lx, that is L to the power of half and g to the power of minus half and m to the power of 0. So on substituting for equation 1, you have half minus half and 0. So now we are supposed to take it out, that is, since k is constant, I can give it as 2 pi. It's a constant term, 2 pi. So time period is equal to 2 pi and L half represents root of L and g minus half represents root of g itself, but it is minus, so it comes to the denominator. So root of 1 by g. So L half is nothing but root L and g minus half is nothing but root of 1 by g. So g has to go to denominator when there is minus here, negative on the power. So how are we splitting up this L half and g into minus half? So it is root of L by g. So t is equal to 2 pi into root of L by g and m to the power of 0, that is 1. So there is nothing to be calculated there. M to the power of 0. Something to the power of 0 is always 1. Okay, so it is T is equal to 2 pi root of L by G. That is the time period. That is the expression for the time period. This method can be used in order to check out the independent physical quantity relation of independent physical quantities, but it can't give the exact relationship between the physical quantities. This is all about your deducing the relations among the physical quantities. So in today's class, we have studied regarding the dimensional formula, two types, that is for base quantities as well as for derived quantities. So how are we going to derive the dimension for the quantities as well as the applications of dimensional formula, and you have also deduced the relation of a physical quantity, that is for time period. So that's all for today. Let us all meet in the next session with a new chapter. Until then, thank you one and all.